Now it's time to talk about versioning. Let's start with a little bit of motivation and some definitions. Think about a platform like Windows. When Windows updates, the new version generally will have additional APIs that weren't present in the previous versions. On the customer side, some customers will update their devices to run the new version of the platform, and some won't. As an app developer, traditionally, this led to kind of a dilemma. Do you update your app to use the new APIs? This means your app would only be installable on customer devices that have updated their platform. So you would be reducing the size of your market share potentially. Or do you stick with the old API? In this case, yes, you maximize your potential target market, but your app can't take advantage of the new APIs to offer the users updated features. UWP helps to eliminate this trade-off by letting you write what's called version adaptive code. So you write one app, and that app can be installed on all devices here, the old and the newly updated devices. When your app is running on a new updated device, you can use the new APIs. When it's running on the old APIs, it degrades gracefully or reduces the features available to the user just to accommodate what's available on that platform. So in some ways, this is the best of both worlds. You get to maximize your target market and use the new features when they're available. Now we're going to talk about how your app targets the different versions of Windows. There's several things to talk about here. Let's start with the versions of Windows itself. So at the time I'm recording this, there are currently 3 versions of Windows 10 that have been released. 10.2.40, 10.5.86, and 14.3.9.3. Your application has to give 2 target version numbers, min version and max version tested. Min version is for installation. It defines which versions of Windows your app is allowed to be installed on. Max version testing is for API behavior. That one's tricky. We'll talk about each of these in turn here. Start with min version. Let's say you set 10.5.86 as your app's min version. That means the store will allow your app to be installed on customer devices that are running version 10.5.86 or higher. Max version tested, this is the one that's a little trickier. Suppose you set 10.2.40 as your max version tested. That means your app has never been run on, as far as you're concerned, on a device that has one of these higher numbered versions of Windows running on it. Now suppose one of the APIs changed between these releases. And by changed here, I mean it's not a new API. It didn't change its interface or its name or its parameter list. Its behavior actually changed. Could have been a bug fix, but more likely it's need to fix a security hole, comply with some industry standard. Who knows? There's many reasons why the underlying behavior of an API like a method might have changed between Windows releases. So now this method that you're calling, let's say in version 10.5.86 and 14.3.93, has different behavior than the 10.2.40 behavior. Your app has never been tested with the version in these updated Windows releases. At runtime, suppose you were installed and running on a customer device that was running Windows 14.3.9.3, and you call that method. Which behavior would you prefer to get in this case? The old version that you know and that you tested against, or the new behavior that you've never seen, you've never done any testing with? So that's a bit of a rhetorical question. The behavior you actually get is the 10.2.40 behavior. And this is called a quirk. If you're interested in further discussion, that's the term to look for. It's kind of a complex issue, but it is important to know at least the basics here, because you're required to set max version tested for your app. And if you read the documentation for max version tested, it does discuss that it's used to implement this kind of quirk behavior. So there's 2 version numbers that you have to set. You have a couple of options where you can set them. In your manifest, that's the main way. There's a special case that lets you put them in your CS proj file instead. So we'll look at both. Here's the manifest one. So right here we have a target of Windows Mobile. That means, since this is not, say, universal, that means that we are required to give the version numbers here, min version, max version tested, in our manifest. And you can see that I'm using the Windows version numbers that we've seen a few times now. So when you're not targeting universal, the exact values are required in your manifest. On the other hand, if you are targeting universal, see right here it says Windows Universal, then optionally, you don't have to do this, but optionally you can give these special values here for both of them, 10,000. And this special value is just a marker that tells the Visual Studio toolchain to pull the version numbers from your CS proj file with these element names right here. And really the big benefit of doing this is that in the project properties has a GUI that exposes these two numbers right here, these two values, whereas if you set them in your manifest, you have to edit the manifest manually. We just talked a lot about Windows version numbers. Now it's time to relate those ideas to API contracts. Each new release of Windows does bring with it changes to the API contracts. For example, here's calls phone. Each of the 3 current releases of Windows have brought updates to that API contract. And each of these changes here added new classes or added new members to existing classes. This pattern here where you see each new release of Windows revving the API contract, that's not the only one that's possible. This one didn't rev at all. This one only revved between the first and second Windows release, this one between the first and third, and this one appeared in the second release and didn't exist at all in 10.2.40. And finally, this one's the most interesting, I think. Sometimes API contracts disappear. This one calls voice over IP. It was its own API contract in 10.2.40, but then it was pulled into the universal API contract in 10.5.86. So it ceased to exist as an independent API contract. Each new release of an API contract does typically add new features. Here's calls phone. So version 2.0 introduced the phone call origin class. Version 3.0 added another class, phone call origin manager, and added properties to the existing phone call origin class. Now remember that your app may be running on any of these versions of Windows, of course, depending on what you set as your min version. But let's say you set 10.2.40 as your min version, then really your app may be running on any one of these 3. Which one you're running on determines which version of the API contract is available. So if you were trying to use calls phone, if you found yourself running on 10.2.40, only the version 1 implementation of that contract's available. If you're on version 2, then you can use that phone call origin class. If you're on version 3, you can use the phone call origin manager class and the additional properties that were added to phone call origin. Finally, we get to the core of the idea here. Remember, our goal is to write version adaptive code, meaning when we're running on a new version of a platform, new version of an API contract, we use those updated APIs. And to determine what is available to us, we again use the API information class and the isAPIContractPresent method. This time though, we're interested in these last parameters, major and minor version. Let me go back here to this slide. So we have things calls phone v1.0. So 1 is the major version and 0 is the minor version. Those are the numbers that you would pass in here. We're going to be testing for API contract version. So our code is going to be asking, is API contract, and we're passing in the name here, and then 1.10, 20, 30, and so on. We are not testing for Windows versions. But here's an example on how to do it. This is the calls phone example. If we're running on a device that has version 3 available, then we have the display picture available to us. If not, it's okay, we'll just skip this code. Then we do another test. Are we running on a device that has version 2 available? If so, we'll include the display name. If not, well, we'll skip it and just go to this one. If version 1 is available, then we'll include this one, which has been there since version 1. So this is the way you write version adaptive code. Depending on, at runtime, what version is available, your app will change its behavior. So again, we've sort of achieved our goal. We have one app that is installable across all these different versions and behaves differently depending on which APIs are available at runtime.